Hello friends, welcome to the channel. Today we are going to learn here preparation of alkanes. So let's begin. First of all, we learn about the industrial source of alkanes. So petroleum and natural gas are the sources of alkanes. When dead plants buried under earth billions of years ago got converted into crude oil under the high temperature and pressure condition. Alkanes are obtained by fractional distillation of this crude oil in oil refineries. So this is a industrial source of alkanes. Now we understand here some preparation method of alkanes. First of all, we start with the method of from unsaturated hydrocarbons, that we call it as a hydrogenation method. So in this method, dihydrogen gas added to the alkene or alkyne in the presence of platinum, palladium or nickel catalyst to form alkane. So this method we call it as a hydrogenation. What is meant by hydrogenation? Hydrogenation means addition of hydrogen. Addition of hydrogen. That's why we called it as a hydrogenation. So in this method, dihydrogen gas adsorb onto the surface of this type of metals, and this activate the hydrogen-hydrogen bond. In this case, here we used platinum, palladium or nickel. Platinum or palladium or nickel. This catalyst we used for the hydrogenation. Platinum or palladium catalyze reaction at room temperature, but for nickel, high temperature and pressure is required. Means here, by using platinum or palladium, these catalyze the reaction at room temperature, but for nickel, high temperature and pressure conditions are required. So in this case, we will see these examples. Suppose here we take example of ethene. When ethene react with dihydrogen gas, here dihydrogen gas means it is a H2 molecule. H2 molecule. So from these two hydrogen atoms, one hydrogen atom is attached to the first carbon, another hydrogen atom attached to the second carbon to form a ethene. To form a ethene. This reaction is carried out in the presence of metal catalyst like platinum, palladium or nickel. Similarly, we take here another example. In this example, propene CH3 CH double bond CH2. Here this is also the alkene, and this alkene propene react with dihydrogen gas in the presence of platinum, palladium or nickel catalyst. Here this is a H2 molecule. Here one of the hydrogen atom attached to this carbon atom, another hydrogen atom is attached to this carbon atom, and it is converted into propane. Similarly, we take here another example of alkyne. So here a triple bond is there, that's why we called it as a alkyne. That is a propane. 3 carbons are there, 1, 2 and 3 carbons are there. That's why this is a propane. And this propane react with dihydrogen gas in the presence of platinum, palladium or nickel catalyst. Here this H2 molecule, one of the hydrogen is attached to this, here 2 hydrogen atoms attached to this carbon atom and 2 hydrogen atoms attached to this carbon atom. Here triple bond is converted into single bond. Means here 2 H2 molecule is required. Okay, so we get here propane. So this reaction also catalyzed in the presence of catalyst, that is platinum, palladium or nickel. So we get here the alkanes from unsaturated hydrocarbons by the process of hydrogenation. Hydrogenation means addition of hydrogen. Now we see here another method for the preparation of alkanes from alkyl halide. Alkyl halide. Alkyl halide means R bond X. R bond X means R means alkyl group, that is methyl, ethyl, propyl. Okay, and halogens means chloride, bromide, like the halogens. So these are the halides, alkyl halides. So see here, alkyl halides except difluorides, means here difluorides is not used, undergo reduction with zinc, reduction with zinc and dilute hydrochloric acid gives alkanes. Means this reaction is a reduction reaction. Reduction means one of the definition of reduction is addition of hydrogen, addition of hydrogen. So this is a addition of hydrogen. This addition carried out, this reduction carried out in the presence of zinc and dilute hydrochloric acid, and we get here alkanes. To understand this, we take here an example, that is chloromethane. Chloromethane, this is also the alkyl halide. Alkyl halide, this is a CH3 group, means alkyl group, and chlorine is a halide group. This alkyl halide undergo reduction in the presence of hydrogen, uh, and here catalyst used is zinc or dilute hydrochloric acid. What happen here, from alkyl halides and from H2 molecule, one of the hydrogen, that is H and Cl, is removed as a HCl, and this remaining hydrogen attached to this alkyl group. So to form alkane means CH3 and H form CH4, and this hydrogen and Cl is removed as a HCl. So in this way there is a formation of alkane. Now we take here second method, second example, chloroethane. Chloroethane. In this chloroethane react with H2 in the presence of zinc and dilute HCl. Here acid is represented by H plus. Okay, HCl is acid. That's why we represented here HCl as a H plus. So here chloro from chloroethane and one of the hydrogen from H2 molecule is removed as a HCl, and remaining hydrogen is attached to this alkyl group to form alkane, that is C2H5 and hydrogen C2H6. We get here ethane. Similarly, we take here third example. Here N-propyl chloride react with H2 in presence of Zn and H plus. Here similarly one of the halogen and one of the hydrogen is removed as a HCl, and remaining hydrogen is attached to this CH2 to form CH3, and we get here propane. So this is a method by which we prepare alkane. Now we understand next method for preparation of alkanes is a Wurtz reaction. In the Wurtz reaction, alkyl halide, here also we used alkyl halide on treatment with sodium metal in a dry ether solution to give higher alkanes. So this method we called it as a Wurtz reaction. So what is a Wurtz reaction? Alkyl halide on treatment with sodium metal in dry ether to form higher alkanes. So this reaction we called it as a Wurtz reaction. So see here, this is alkyl halide, that is bromomethane. This is another molecule of bromomethane. So here two molecules of bromomethane react with sodium metal in a dry ether solvent. In a dry ether, what happen here, two sodium atom and two halide atoms of alkyl halides are removed as a twice NaBr, and remaining alkyl groups are joined together to form ethane. Means here these two methyl groups are joined together to form ethane. So this is alkane. So here we prepared alkane from alkyl halide. Here two molecules of alkyl halide react with sodium metal in presence of dry ether. We get here alkane, and here twice NaBr is removed as a side product. Now we take here another example of this Wurtz reaction. Here we take alkyl halide as a bromoethane. Bromoethane. This is also the bromoethane. React with two sodium metal, two sodium atoms of two sodium atoms. What happen? This reaction is carried out in the presence of dry ether. Here this twice sodium atom and 2 Br atom are removed as a twice NaBr, and remaining C2H5 and C2H5 join together to form N butane, So this is a method by which we get here a alkane. Now we see here another method for the preparation of alkanes, that is from alkyl magnesium halide. Alkyl magnesium halide means Grignard reagent. We call it as a Grignard reagent. First of all, we know how Grignard reagent is formed. We see here preparation of Grignard reagent. How Grignard reagent is formed? Grignard reagent is formed by reaction of alkyl halide with dry magnesium metal in the presence of dry ether. Alkyl halide react with dry magnesium metal in the presence of dry ether. We get here alkyl magnesium halide. So we call it as a Grignard reagent. This reagent we also called it as a Grignard reagent. So this Grignard reagent react with water. This Grignard reagent react with water. Here we write Grignard reagent RMgX. This is a Grignard reagent. React with water. Water means H2O. Okay, H2O. What happen here? Here Mgx and HO. Mgx from Grignard reagent and HO from water is removed. Okay, and remaining R and H are joined together to form a alkane. So this is a general reaction. Now we understand this reaction with the help of example. What is the example? Here methyl magnesium iodide, this is a Grignard reagent. Methyl magnesium iodide react with water molecule in the presence of dry ether. What happening here? Magnesium iodide and HO is removed as a MgIOH, and remaining CS3 and hydrogen are joined together to form a methane. Methane means alkane. So this is a method for preparation of alkane from Grignard reagent. Now we see here another method for the preparation of alkanes, that is from carboxylic acid. Here sodium salt of carboxylic acid undergo heating with soda lime. What is soda lime? Mixture of sodium hydroxide and calcium oxide. So this is a soda lime. So we get here alkane. But when we see this alkane containing one carbon less than the corresponding carboxylic acid. Means here see that this is a sodium salt of carboxylic acid containing two carbons, but here is one carbon. Means here this CO2 molecule is removed. That's why this reaction is of decarboxylation. Here CO2 is removed. So this is a decarboxylation reaction. So what happened? We see here example sodium ethanoate. So this is the sodium salt of carboxylic acid, sodium ethanoate, undergo reaction with soda lime, that is sodium hydroxide and calcium oxide, undergo heating. What happen here? Suppose one hydrogen and CS3 is removed as a CH, and here two sodium atoms form Na2, and here this oxygen and CO2 is removed as a CO2. So Na2 CO3. We get here the alkane. So this is a method for the preparation of alkane by the decarboxylation method. Now we see here another method for the preparation of alkane, that is Kolbe's electrolytic method. An aqueous solution of sodium or potassium salt of carboxylic acid on electrolysis gives alkane containing even number of carbon atom at the anode. So this is a method, we called it as a Kolbe's electrolytic method. Here this is a sodium acetate. Two molecules of sodium acetate react with two molecules of water, undergo electrolysis to form ethane plus twice CO2, H2 and twice NaOH. Here 2CH3 forms here ethane. Here two CO2 molecules are also there. Two CO2 molecules remove. Here two sodium atoms are there. Two sodium atoms and 2 OH from H2 from twice NaOH and remaining H2. Okay, so in this way we can prepare here alkane from sodium acetate, that is ethane. Here we prepare ethane by Kolbe's electrolytic method. So these are the different method for the preparation of alkanes. If this video help you to understand preparation of alkanes clearly, then like, share and subscribe to the channel for more chemistry lessons. Thanks for watching.